Good evening, all of you. Can all of you hear me, guys?
Yes, sir.
Yeah, thank you, thank you. Thank you for joining and making the event happen. So, since it was a last minute call, I could see people from postgraduate students have been joining from all over the world. I can see Wang Jing and I can see Amelia from UAE. Ibrahim. So thanks all of you. Thank you guys. And Sarmin, Sultana, thank you. If you are very close around, you can also walk in and you can have the session. So let me just give a short brief what we are going to have today. So we are very much delighted and happy, and I'm very much happy to introduce our professor, Dr. Amlan Chakravarti. So Professor is associated with us for past 7 years. Professor was the initiative person who was there in the initial days of our postgraduate. So all our postgraduate programs, starting from Master of Computer Science, PhD in IT, and PhD in Computer Science, Master of Computing. So all those programs, Professor was a key person, and on his guidance and support we have done. And also we have indulged in a lot of research activities, and we are very proud to have professor in here in our floor today, and we are very much happy that our students could get a chance for having a session and a technical talk on data science. To give a brief introduction about Prof is the Dean and full professor in Information Technology Department of A.K. Chowdhury School of Information Technology, University of Calcutta. And Prof has a lot of immense achievements and records. I cannot even figure it out if I can read out because a lot of experience. And Prof is also a key person in University of Calcutta. And most of you might know by if you have searched in Google, you will find a lot of information about Prof. Prof has been associated with a lot of reputed institutions, international universities all around the world, especially University of Cambridge, City University of London, University of Oradea, Romania, and SUNY Buffalo, USA. And by in that sequence, we are very proud. Lincoln is also one of them, and we are delighted and hope all of you will get a very good session, and you will get an informative and you can enrich your idea on data science. Thanks for all joining. It's all over you.
Thank you. So I'll start from here.
Yes, Professor.
Okay. So thanks, Professor Midun, for your brief introduction. And yeah, so as you rightly said, that I am very well connected. Due to my busy association in my university and international, I couldn't visit very often, and also the COVID was there, so I couldn't visit very often to Lincoln. But Lincoln is always very close to me. The faculties here, right, we did a lot of work together, and we are still fresh in our mind. So, so thanks again, Dr. Deepa and Dr. Midun, for inviting me and to introduce me to the students of this department. And I hope that this department is doing very good. I have got some information feedback about the students, about the PhD work going on, and I see that it gives me a great feeling that the department is doing very good. So, so for the past few years, I am mostly working in the domain of AI, machine learning, data science. So I thought that I will be giving a very this is not a very a class on a specific topic. What I will try to show you is that the potential of artificial intelligence and machine learning and data science together, right, in the present scenario of science and technology. And that gives a lot of scope of research, a lot of scope of industry collaborations. Okay, so let's start. I will start my presentation. Is it connected? Let's check. Yeah. So how will we do that? Thank you. I have the John due to COVID. All the things happened in Zoom. And for now, it's there. Okay. Perfect. Yeah, so I hope that that means my slide is visible to all of you. So title is artificial intelligence and its multidisciplinary research opportunities. Right, very perfect for the faculties and the postgraduate students and researchers. So I will be very brief. Right, I will start with why artificial intelligence is the driver of the century. What are the trends in AI and ML, and then I will very quickly touch some of the activities of my group in this domain. So this is a famous quote from Bill Gates, right, who said that we always overestimate the change that will occur in the next 2 years, right, and underestimate that that will occur in the change that will occur in the next 10. So what it means that means might be the machine learning or the AI what we started, right, and it started almost around 1940s, right. If you look into the initial work of this of the AI and neural network, you will see that it started in 1950. So might be we didn't progress much on that particular time, the AI and ML, right, because there are a lot of expectations, but it failed a bit. But if you see the present scenario, right, basically after 1990s, right, when we got a lot of the data, right, data working, right, and from 2000 when deep learning came into existence, right, what happened is that the things actually move very fast, right, and now what is happening now, before we are thinking that, okay, if you look into something that, yeah, this is a very challenging thing, whether it is already there, we will see that somewhere it is done, right. Most of the things which were completely unimaginable, like the driverless car, right? Nobody would have imagined maybe 5-8 years ago that that there will be driverless cars, right? There will be robots which will be working in the very precision process engineering domain, right? That everything is now being done. There are pathological tests and radiological analysis are being done in an automated way through the AI and machine learning. Drug discovery is being done through AI. So these are the things which are actually with, that means that, okay, so if we thought about previous experience with AI, it was a slow process and people will not be there was an expectation, high expectation, that it got slowed down, but now in the next maybe we will see a tremendous change in the next 3 years, right, in the different applications. So that's why this AI and ML, right, is very aggressive Okay, might not be for the next 10 years, within 3, 4, 5 years, we will see rapid changes, right? Now, if we look into the trends in AI applications, right, it has now covered in most of the areas, right, in terms of technology, in terms of business, right, in terms of infrastructure. So now the AI and ML are not only running in the so-called computers, right? AI and ML, for AI and ML algorithms, we have different types of infrastructures. We have cloud, we have the IoT, and the edge computing is also coming in a great way. So all this, depending on the latency, right? Obviously, that means we will try to work the AI and ML algorithms at the cloud because they are very complex algorithms normally. So cloud has a large infrastructure to support that. Obviously, the data also, but cloud has a very large latency. So for the latency, we are now focusing on the edges, right? Edges are maybe the small computing infrastructure, much smaller than the cloud, but they can do a certain amount of computation. So we are looking into that, whether can we run the AI and ML algorithms at the edge, right? And so what we are trying to move is a sort of very specific AI to a very generic AI, right? Which means that our algorithms should not only cover a particular type of systems, but we will actually try to cover a large number of systems, right? And if you look into the services, what not has been done through this AI and ML, right? We have services to that is in business, in medical, in the judicial, in education, in the day-to-day services of the common people, and a lot of AI services have now come up. So now why this technology is creating a great impact? This technology is creating a great impact because it is not for our only scientific or technological engagement, or it is not only for our supporting our intellectual effort. It is really generating value to the business. We have to remember that there are many technologies came and many technologies were initiated, but they couldn't got sustenance because there was no business in those technology areas. AI and ML is creating tremendous business opportunities, and that's why this is the technology which has stayed and which is going to stay for a long years. Now, why? First of all, that AI and ML gives you a process automation. Process automation means you don't require the manual intervention. There, the decision is being taken by the machine itself, right? Why we require humans? We require humans because we need to take decisions on what to be done when and what to be done next. Now, these decisions are now driven by your AI logic, right, or your ML logic. So these decisions are now being automated, and so we have a process automation. Secondly is the cognitive insight. Cognitive insight means that you have some sort of intelligence, okay, which you can explore the data, right, where the data science comes, right, to a great extent. So when you go to a shopping mall, right, the shopping mall person will tell that, hey, can you just use our card or register to our membership, right? Now, due to the membership, we get a sort of discount, right? They will tell that, hey, you will get a 5% discount on every purchase from here, right? And we actually take the membership and go ahead with it. But actually, what is being done through this particular membership, the particular shopping mall is actually capturing a huge amount of data of the customers. Okay, what are their location, okay, what type of ethnic group they are belonging, what type of products they are buying, what is their purchase capacity, what type of job they are doing, right? What is the income status? So based on this huge customer data, they are now generating a lot of promotions, right? Different types of promotional activity for different groups of people. So what it means that which was not so evident of a shopping mall owner, that what needs to be purchased and how much quantity needs to be purchased, right? Whom to be given what discount. These all things become very clear once we have a large amount of data. right? So this type of decision-making ability, right, okay, from which is not so apparent, but you can give a deep thought and you can generate the decision. Those type of cognitive insights are coming, and through this cognitive insight, what is generating is cognitive engagement, right? I am very happy if my shopping mall can give me the exact type of product or exact type of supply what I require, right? And how shopping mall does that, or say how Amazon or all these shopping portals does that, because they actually try to connect you in the cognitive domain, right? So from the data domain, it is moving into the data insights and data decisions, which is actually the cognitive, right? And so this cognitive engagement makes the customer happy, and so the business grows. Okay, so that's the contribution in the work process. Now, what is the tangible outcome, right? You have to tell what is the, okay, these are very good process activities, but what is the tangible outcome? So tangible outcome is to enhance the customer experience. So customer experience gets enhanced. The customer feels that there is always a sort of, that means before you go to the Amazon, based on your last shopping, Amazon will give you some sort of suggestions that, hey, will you want this or do you want that? So the customer feels that, okay, hey, Amazon is working for me, right? This makes a customer happy, right? Reduces the cost, because what you try to do here is that means you cut down your unnecessary operations, right? In business, operation cost is enormous. So you categorize the operations which are really worthy, right? And you see the operations which are not paying you money, paying you any value. So you can reduce those operations tremendously, and you can enhance those operations, right, which is giving you good revenue. So that is actually a sort of reduction of the cost, right? Now, the third point is the creation of new revenue, because this AI and ML are generating a lot of new services. Okay, the services such that hey, you are booking a ticket for your air travel, right? And AI, and through those portals are also offered based on your location, based on your air travel options, right? It is also pushing you the hotel or the travel or the car travel options. So it means that there are immense number of services which can be plugged together, right, based on the data what you have your customer, right? And this convergence of services are the new sources of revenues. Okay, so this AI and ML are actually technologies which are not only for satisfying the intellectual need of the scientists and researchers, but they are really driving the business, right? And that's why it is so important. Now, if you look into the domain of machine learning, okay, it's everywhere, right? Nowadays, I think the younger generations are more, they know more than what is happening in the AI, because everywhere in the virtual world it is AI, right? AI and ML. So if you see for the games, if we go for our digital platforms, for our entertainments, recommendation systems, right? Or they work on this ML. Drug discovery, where we try to focus on, hey, what is the disease pattern, what is the genetic information, and what is the molecular information of the compound which can actually make the body drug resistant. So we need to do a huge amount of search. So this large amount of search in the data space can only be done if we can, if we can actually do this type of activity using the artificial intelligence or machine learning. Now, in the character recognition, stock predictions, your chatbots, right, driving assistance, security systems, biometrics, automated facial recognition, and classifying that whether you have some, that means you are my good friend to enter my house or office, or you are not in my friend, right? Automatically, that means we don't have to go to the door and we have to open and close the door, right? The door will automatically open or close based on the recognition process. There are tremendous work is going on the medical diagnosis using this machine learning techniques and deep learning techniques, where they try to detect the disease, right, in an automated way. You give me the scan reports, right? Obviously, doctor is there to go through that, but what happens in many of the countries, the doctors are pretty less, right, and the patients are pretty high, right? If you go to India, right, in rural areas, you have a lot of people who okay, right, and to staff the doctor is less. So similarly, there are some other countries also like this. So this automated diagnosis process actually helps you to at least help the doctor to at least segregate that, hey, these diseases are really taken to be care very soon, because they are really at a very critical stage, right? And these diseases are not all diseases, right? And there are some moderate diseases in some of the patients. So the doctor at least can understand that what are the depth of the diseases based on the data. Obviously, it's the doctor takes the decision with the support from the tool, and that helps the doctors to do the decision fast. So there are many other things which you can add to this AI-enabled gamut, but these are very interesting things. Okay. So now let us get into the fundamentals of the subject, right? So I have discussed about the scenarios, what are the interesting scenarios, and how, why it is so important to know AI and ML in the present era. Now let's get into the more fundamental. What are the main pillars of machine learning, right? So machine learning was coined as something which is some, that means you are executing you're executing a computational process, but this computational process is not being explicitly programmed, right? This was told by Arthur Samuels. Now, what this exactly means, right? So explicitly programmed means we know that when we try to describe a program is described by its data flow, right? We know that a program means that we know the mathematical function, right, or the logical operations which can take certain parameters from the input and can produce a result, right? The program means that. Now there are many areas where you cannot find the mathematical expression or mathematical function, right? For example, suppose I tell you that can you estimate the yield of a crop in a particular region based on its rainfall pattern, based on its soil condition, based on the type of the crop, right? Can you tell me what will be the amount of yield of a crop? Now, this is a difficult thing to program because you don't have the mathematical model which will establish that, hey, the yield y equals to alpha x square rainfall plus beta x square 5 parameters of the soil plus gamma gamma z square of the crop properties. You cannot have this mathematical model. So if you don't have the mathematical model, you cannot write a program to evaluate the yield of the particular crop. Okay, so this is a challenge, right? So we cannot do this. We cannot solve this problem when we have that if we using the explicit programming. So what we can do, we can use machine learning. So what machine learning tells you that, right? Okay, that's it. Okay. There will be an analytical model, obviously, but the analytical model is either very complicated, right, or I am not the domain expert to form the analytical model. Okay, so what I do, right, I use my past experience. Say, can you give me the data of the last 10 years of this particular region? What was the temperature? What was the average rainfall? What was the soil condition? And what was the crop yield for the last 10 years. If you give me the data, then based on the data, I can generate a hypothesis, right? And that hypothesis will correlate. Okay, it's a prediction problem. That hypothesis will correlate the parameters like rainfall, soil condition, okay, crop variety informations, and we'll try to use the data. What was the yield value? And based on that, it will generate a hypothesis. And this hypothesis, can work if you give me the present parameters. This hypothesis can tell what will be the yield. So it means that this is the model which I'm speaking about. So this is called a machine learning model, which is basically a hypothesis which actually is built on the data or the past experience. Okay, there is another part of this, right? Okay, that means how you can tell that your machine learning is performing well. That was also coined by Tom Michels in 1997. So what was said is that a machine learning task, right, if it goes on generating, right, more and more you supply the knowledge to it. Okay, more and more it works on the data, right? More and more it gets refined, right? And more it actually performs well. So the performance of a machine learning model is that means is proportional or is directly related to the amount of experience. Now, this experience is called the learning. So you have the past samples, right, based on which you generate the learning, and right, and if you increase the quantity of past samples, means that, hey, can we predict the agricultural yield based on the data of last 2 years? Okay, right. If you try to build a model based on the data of the last 2 years, it will not be so good, right? If you do it for using the data of the last 5 years, it will be better. If you do it for the last 10 years, it will be much better. Why? Because more and more samples you collect, more and more variations of the domain is there. So your knowledge in a domain is not a static thing, right? Knowledge in a domain is a variable, which means that if you can collect enough amount of samples, you can trace the variability existing in the domain, and that variability of the domain can be now trapped to the learning and the knowledge of your system, of your artificial intelligence system. So that's why you require large amount of data, a large amount of samples by which you can build up this learning model. Okay, so ultimately the machine learning is basically developing a computer program, okay, which can use data, right, and can capture the knowledge existing in the domain, right? And if you can capture the knowledge existing in the domain in a proper way, then for the next data, right, you can predict what will be the outcome because you have captured the knowledge. Okay, so there are a lot of problems you can discuss in this domain. Like traffic pattern is a very common problem. That can you predict the traffic pattern of a particular hour of the day, right, in a particular busy region of your city. So what you need to do, you need to actually capture the past data, right? The past data of a long range, maybe for the last 5 years, right, of the data, right? Different hours of the particular busy street, right, in different time of the day, right, for the last 5 years. What was the traffic pattern? Right? Based on that, I think you can develop a model, right, and then you can tell that, hey, this is the hour where we want to predict the traffic pattern, right? Provided the model is good, right, it will generate the result. Okay, so this is also very, very important, that how I know that the model has learned well. So there are certain metrics, okay, there are certain performance metrics, right, by which we can estimate the learning, the quality of learning of a model. Okay, basically technically it's called a loss function, or defined in terms of an error if you are training in a supervised learning mode, right, and then you can refining the model, right, unless your error is below a certain level. So if we see this, so if we see this particular scenario, right, this comes to again a very simple understanding of what is machine learning once again. So suppose a traditional programming, right, I tell one of my students to write a program which is a square root finder, right? Obviously my student will try to get the mathematical model of a square root finder, which is a sort of series, right, and try to describe that mathematical that particular series addition or series function, right, in the computer language. And then what we have, once the computer program is built, right, I supply the program to my computer, right? And then I pass my input data. Suppose I give 4, my program will give 2. But this is the normal way I do traditional programming, right? Which means that I have to find a particular solution in terms of mathematical and logical expression. If you can find a solution in terms of mathematical and logical expression, right, you can develop a computer model, okay, right? And then once the model, once the program is built, so not the model, the program, okay, once the program is built, right, you can pass a new data and it will generate the output. Now let us try to come in a different way. Now, then what is machine learning? So machine learning, I will not tell that, hey, give me a square root formula. What I will tell you is that, can you develop a program when I will give 4, it will give 2, when I will give 9, it will give 3, when I will give 16, it will give 4, when I will give 25, it will give 5, and so on and on. So what it means is that I will tell that, hey, I am giving you the input and output, right, and then try to generate a sort of model based on the input I give and the corresponding output, right? Try to extract the knowledge, try to build the model, and then you apply the model on the new data. So what we do in the machine learning is that actually the learning part of machine learning is we build this program based on the given data, past data, and the corresponding output of the past data. So provided we collect the past data and its output, and we build the program, then what happens? Then this program is called now the model, and now this model can work for a new data and can provide the outcome, provide the output. So this is what is the difference between a machine learning and a traditional programming. Okay, now there is a word of caution. The word of caution is that there is a tendency of many of the students and young researchers that to try to think every problem as a machine learning problem, right? It is not like that, right? Don't get that in your mind, right? There are enough computational algorithms which are existing, right, which performs very well, right, provided you have a very good analytical solution for the problems. If you have a very good analytical solution for the problem, there is no point in doing machine learning. The machine learning are only for those problems where we don't have analytical solutions, or analytical solutions are pretty costly, right? That means either you don't have the domain knowledge to build the analytical solutions, right, or you cannot, or it consists of too many parameters and too many things to build the analytical model, right? Or it's very too complex, the analytical model. So then you can try machine learning. Okay, so that's why we are telling what is the essence of machine learning. So this is again an example. We know that the reinforcement learning for what we are doing in the deep networks now, was actually motivated by the Netflix competition. So Netflix actually proposed a competition that, hey, can we build a recommendation system which can improve my viewers, right? And there at least this worked, right? So machine learning actually gave some real growth in the business, right? There are some real data which shows that machine learning paid very well. Now, again, as I said, that when machine learning can help when we understand there's a pattern exists. Okay, there is a pattern of rainfall, there is a pattern of my disease, there's a typical pattern of expression, there's a typical pattern in my text. So if this pattern exists, then I can actually analyze it using machine learning. Second is that we cannot pin it down mathematically. It means we cannot write we know what is x, and provided a given x, what is y, but we don't know how we form fx. Okay, so fx is a function which accepts x and produces y. So in machine learning, we know that what is x and what is y, but we cannot generate the fx because that function is unknown to me. I don't have the mathematical rule to generate fx. So that's what is called a then machine learning comes. And the third most important thing is that we have the data, right? You can only generate knowing X and knowing X and corresponding Y. You can approximate or you can make a hypothesis for Fx only if you provide me a large amount of X and the corresponding Y. If you give me a small amount of X and the corresponding Y, right, I cannot capture the knowledge existing in the domain and I cannot form a machine learning model. So we need to have enough amount of data to drive the machine learning models. Okay. Now, if we look into the present scenario of this AI, right? How it is, how the trends are getting into, right? The important trend of AI is called formative AI. Okay, what is this formative AI? The formative AI is something which can adapt very quickly, right? It can dynamically change to respond to a situation. So many of the robotics application, driverless car applications, where there are robust scenario in the environment and the system has to adapt. In that particular environment, you need to actually use this type of techniques where the techniques like reinforcement learning, one-shot learning, so all these types of faster learning techniques and adaptability are coming into the process. Okay. The second important progress in the domain of AI is the neuromorphic hardware. So what is this? The neuromorphic hardware. So the computations which are basically run by the neural network computations which we are normally do in the present deep network scenarios, though we compute the neural network, but we don't actually compute in the way the neurons function. Still, we use the same type of classical ALU architecture to compute the neural network operations. So now the progress goes into this direction that, hey, can we not process the data, or can we have a processing hardware, right, which is exactly similar to how neuron processes. So how neuron processes, neuron takes the data from the inputs, right, and combines them with the weight, right, and then it does a cumulative operation, right, and then it works on a switching function, a nonlinear switching function which generates a sort of threshold-based output. So what it means is, can we define our entire computation on that way, that is the memory, the distributed memory and the localized computing process, right? Can we do a large amount of distributed computing? What happens in the large number of neurons, right? What happens in our brain system? So can we define the hardware in that way so that we don't need to map the computing of neural network in a different way when it goes to a normal classical classical CPU type of architecture. So neuromorphic chip having the large number of computing resources. Remember that when we tell large number of computing resources, these computing resources are very, very small in their capability, because each neuron is your hardware now. So you're mapping your neuron to a particular hardware. Now this hardware need not to be very complex, because each neuron is not very complex. They do very simple computations. So each of the core can be very simple, but what you need a large number of cores, which resembles a network, as it is a neural network, and we require the memory which can supply your weights to all of these neurons. So if we can develop neurons in the hardware and process the data exactly how it is done in the neural network, then it's called a neuromorphic hardware. And a lot of progress has been done in this, and it's expected that this neuromorphic hardware will perform this network-based algorithms, neural network-based algorithms, or deep network-based algorithms much faster. Okay. The next part is the small data, right? So small data, we talk about big data, right? Big data is something where we try to have a big data volume, and we take the data from multiple sources for large intervals, and we try to analyze the data. But it is also required that the small data is also very important. For example, in the case of medical data, in the case of security, right? It is not that the data the data always gives me a security leak, or the data or the health data always gives me a concern about the health. There are certain that means in certain periods of time, right, we have some sort of variations in the data which we need to trap, right? And that is a very small amount of data within a big stack of data, which is very important to me, right? It's not the entire data. There are specific applications. It's right. It's not the customer data. When we tell customer data, it's a big data, obviously. But when we are getting into the scenarios like health information, when we are getting into the scenarios like security, right? There are variations which occurs within a small quanta of time or small quanta of space, right? And that quanta is really small compared to the actual data which is getting stored over the hours. So that is also called the small data, and capturing small data, right, in this scenario is also a good trend, and a lot of applications are coming up now. Okay. The next thing which is also very important is responsible AI. Now, responsible AI comes in two ways, right? One is called the ethical AI, and one is called the explainable AI. So we know that as these machine learning algorithms are being developed through training, right? If we have the biasness in the training, there are a lot of reports which has come up that we have developed an artificial intelligence system, but the artificial intelligence system is biased towards a particular race, or towards a particular skin color, or towards a particular gender, or towards a particular organizations, right? You know that very recently a very big corporation has been sued because it has been found that the search criteria what they have developed is actually biased to their business clients. So if you give a search in a particular that means in a particular platform, I'm not naming the platform. So if you give, right, the search rank is basically, first of all, their direct clients are being shown first. So this is not what is expected, because when you make a contract for a search platform, right, you tell that whatever data is there, we will give it in a proper way, right? You don't mention me that, okay, my customers will be first preferred and then the others. So it is not there in the contract, but you are doing this hiddenly because your search algorithm is trained in that way. So this is called unethical AI, right? Using the biases, using this. So people are using AI because AI is developed by some persons, and it is used by that means if I tell that an AI is developed by 5, right, it will be used by 100. So these 95% are oblivious of what is the algorithm in the AI. They are very much happy if the AI gives them good result. So you can automatically bias this 95%. This 5% people who are developing the AI can bias this 95% very easily by the trick in developing the biasness in the AI algorithms. So this is obviously unethical AI. So it has to be responsible AI now, right? You shouldn't actually go in that direction. The other part of responsibility is called the explainable AI. So explainable AI means that, let's give an example, right? So suppose my AI engine is just like a black box, right? You give me a data and it classifies the data and tells that, hey, this is yes. Okay, this goes to the yes class, or this goes to the no class. But in many of the times you are not satisfied that, okay, that means it is I'm not so much interested to know whether it is yes or no. It is better if you can explain me that why it has gone to yes or why it has gone to no. For example, the common application in the banking is called the risk assessment. So the risk assessment means that you give me the profile of the customer, and my algorithm will tell you that whether the customer is good to give a loan or not good to give a loan. Now, if it is a standard AI, right? And I have built the model with a lot of data, a lot of loan data where the customer information and whether they have received the loan or not received the loan. I have trained my model with that particular data, and then I pass the data of a new customer, and the new customer is graded either yes or no, right? And the customer comes to my office and they tell that, oh, my AI system has said yes, so you are passed, or my AI system has told no, so you don't pass, and then you don't meet me better. So this will not work actually, right? This will not work in the long run dealing with the customers. Similarly, if the doctors are not very happy to get an answer from the AI system that, hey, this is cancerous and this is benign, right? This answer is just a very black box answer. So the doctor will be happy if the AI system tells that, hey, I have made this cancerous cell because the cell size is higher than some count, or the cell has a typical boundary. So I have taken the decisions based on these features which are available in this particular data. So if we can tell that, right, then it becomes an explainable AI. So that explainable AI is coming in a great way nowadays. Okay. The other big contribution which is coming is that can we create that in the digital world, can we create a real world? So this may seems to be a very cinematic word, but this is what has been going on, right? That means you are trying to make your digital world as real as possible. So which means that your structures, right, your artifacts, right, your images, videos, right, all the things will be very similar that happens in the real world. Okay, you're not able to understand, right, whether it is a real or imaginary, right? You know that present day virtual reality is coming in a great way, right? In a virtual reality, right, in the next few years, right, that means, okay, you can just replace a hero, right, with yourself. If you are a male, right, you can replace a hero with yourself and you can be the part of the movie, right? Similarly, a lady can replace the heroine, right, and she can be the part of the movie. So these are the things which are coming up, right? Okay, maybe you are, that means you like a particular sport, and there is a very famous person in the sport, right? And with virtual reality, you can play with him or her, right, in the particular game, right? So these things are coming up in the virtual reality, not only entertainment. This is a huge impact in the case of education and medical, right? Medical doctors can operate, okay, or learn, or can practice a surgery for a complicated operations in a completely 3D virtual reality domain, right? You can listen to a professor in a completely virtual reality class, right, where you may all be in the different parts of the world, right, but all of you can sit in the same class in the virtual reality world. All of the same class, and not only your professor, you can bring 4 or 5 professors, right, across the world, and then they all may be physically in your class to the virtual reality, right? So these are something which are coming up, which may seem to be very, very cinematic, right, at the present point of time, but I'm telling that this is not cinematic, right? Maybe after 3 years, if I come and give you the same lecture, I will already give you the use cases which has come in the digital twins. So these are the digital twins which are coming in a very great way, and this will be getting into that means you can have a lot of negative activities also on this. I'm not focusing on that we scientists and engineers should be very careful that this technology doesn't go in the wrong hands, but if it goes in the good hands, and if you can develop these technologies, it can work wonder, in the present society. So now I will just take that means I will not extend my lecture for, I will just take 5 to 8 minutes more just to finish this. Okay, so these are some of the interesting domain. I will not get into what exactly the details of what we are doing. So this is an exciting domain. There's IoT, data analytics, and fog computing. These are tremendous opportunities. So you capture the data from the using the this is a prototype which has been developed in my lab, and you can we are doing a lot of applications on this. So you can have a structure where you can have an IoT nodes which are connected with the sensors, and the sensors can be depending on the type of applications you are doing. You can pick your sensors, right? If it's environmental, you can do something. In the water, you can do something. Right, for your personal for your personal or health, you can take some other sensors. Right now, the sensors actually connect to the data to the gateway. The gateway can be edge devices or fog devices, and then they can push the data to the cloud. Okay, so and you can build the application or the deploy depending on what type of applications you are doing. Right, it can be there are scope in each of the layers, right? There are scope in a device layer which captures the data, fog layers which integrates the data from coming from some sources of the nodes, and a cloud layer which actually works in a larger spatio-temporal data. So spatio-temporal data means that when you are collecting the data from the IoT nodes, right, you can collect the data from different geographical locations. So this is the spatial distribution. And in a particular location, you can collect the data at different time intervals. This is called the temporal data. So spatio-temporal data is the key, right? How you collect and abstract and how you process the spatio-temporal data, and what is the quantity of spatio-temporal data, what is the latency of the spatio-temporal data. Depending on that, you have to build your resources, like what will be in the device layer, what will be in the fog layer, or what will be in the cloud layer, or whether there will be cloud layer at all, whether you can only do the service from the fog layer. Or in the very, very special cases, whether you don't require a fog or a cloud, you can just build the service in the device layer itself. So these are the decisions that how you need to be taken, right? So I'm just skipping this, I'm not getting into this. So these are some of the projects we have done with the Ministry of IT, Government of India. This is a patent what we have got. So this is okay. So the first one was on water quality. That means we use the sensors to collect the data of the water, and in real time we could predict the quality of the water, right? And similarly, we detected the data of the perishable condition of the fruits using a different type of sensors like gas sensors. So whenever a fruit gets attacked by the microorganisms, they release the carbon dioxide, right? The humidity increases because they release some water, right? And also temperature. So these are the data we collect from the sensors, and we had used a sort of classifier, SVM classifier, right, to get a prediction of what is the quality of the fruit, okay, right? And we also got a patent of Indian patent for the edible fruit, and right. And then there are a lot of things which are coming in the medical image disciplines. Right, we do a lot of work in the medical image disciplines, right? You can okay. This is the case what you do with computer vision using machine learning. So computer aided detection diagnosis means that if you give me a radiograph image, whether it's a digital X-ray or CT, right? I can search the image and I can exactly find that where the deformity lies, right? And I can mark the deformity. So what helps the doctor? So it helps the doctor in actually saving his or her time. That here, this is the region where the deformity exists. The next progress here is that whether we can detect and diagnose also. Diagnose means that whether you can give a risk prediction data, okay, corresponding to a deformity. So whether you can make an index of the risk associated with the deformity. So you can also go into that level, right? You can classify that particular deformity into a low risk, medium risk, or high risk, or maybe depending on the particular domain or particular organ, you can define the disease condition. So these are again the very good areas, okay? So we have done a considerable work in the domain of lung nodule. We worked with a large hospital group called Peerless Hospital, Kolkata. We have developed a data set which is basically the lung data set, right, for the Indian. So there is no lung data set from the Indian patient. This is the first work in India which we have developed using the lung data set for Indian patients, and it's a very large database we have prepared. It's called SWASH because in Hindi SWASH means respiration. So lung is the main organ by which we respire. So that's why the SOSH. Okay. So not getting into the details of this, there are a lot of segmentation algorithms we did using the classifier using random forest classifier and other ensemble classifiers, and we published in good journals. So this I'm skipping now. So there also what we did in the brain segmentation, right? We also did the lesions. So brain has the lesions. Lesions are not always cancers. Lesions require biopsy to determine that whether it's a cancer or whether it's a tuberculosis lesion. So lesions are some signatures in your brain image which are different from the rest, and those are the regions where the doctors have to carefully look, right, and have to either diagnose for the biopsy or have to go for some clinical study or clinical treatment. Okay, so we also worked on this. We also worked on a very good domain called the 3D reconstruction. So this is very important, 3D reconstructions of spine, because spine is a large structure, right? And you cannot actually, in the runtime, if you try to generate the reconstruction, it takes a lot amount of time for the patients, and the cost of an instrument goes high if you can solve a less number of patients. So the problem was that can we solve more number of patients by reducing the amount of images which are required to be captured, okay, to this. And so we did a sort of machine learning for prediction for filling up the volumes of the scanned images, and we generated our own 3D reconstructions algorithms, and we also generated our own slicer, right, which can cut the volume and can give the different types of slices back to the doctors to analyze. So we had a Indian copyright, we had a publication on the IT image processing on this particular work. Okay. Then there are also some recent networks are coming up which are called graph neural networks. Right. What happens is that means we need to reduce the amount of data we need to use for training, so that your training is fast. And if you are doing it on the architectures like Edge, you need to train fast and you need to execute in a low resource. Okay. So what we try to do, we try to develop the ECG algorithm, the ECG bits, right, which are normal and which are abnormal, right. We instead of working with the samples of the bits which normally the people work, right, they sample the bits and they train the train the network with the samples, a large number of samples, so it is a good amount of data, right, we require. So what we did, we converted it to a graph. This is a very novel approach we did for the first time. So we converted it to a graph, and we just try to find out the transitions in the graph, right, based on the normal and the abnormal patterns. And we learned our neural network, right, we learned our multilayer perceptron model, a very lightweight multilayer perceptron model, with this graph data, right, and we showed that it is a lighter training model as well as a lighter network itself, right, and this is by far the best lightweight algorithm still available for detecting abnormal bits in the ECG, and we got it published in the Elsevier Biomedical Signal Processing last year. These are some of the work which we are going into detail. This is also an important work in the security. So security is also an important thing, which is basically in the domain of both embedded and cloud. Embedded are where we do the computing in the devices, and cloud where when you do the computing in the large infrastructures. In both the cases, as we are working with dynamic tasks, a lot of critical tasks, security is one of the very common thing, and we have developed an approach which is called self-aware approach, right? Which is basically how we can learn the environment and we can do accordingly. So we have actually learned different types of threat scenarios. We can learn the threat scenarios, right? And probably when we can learn the threat scenarios, we can classify the threat scenarios, and then based on the classification of the threat scenarios, we can actually take a proper decision, right? In the runtime. And this is the way how the biological organisms also does, right? They save themselves from the predators, from the various predators, the various strategies. So depending on the predators, they change the strategy, right? So similarly, we are actually trying to do this on the security platform, where we try to okay, know the scenarios, the threat scenarios and the signature of the threat scenarios, right? And can we learn those threat scenario signatures well, and we can map those to the classes, right? The classes are how we can mitigate those threat scenarios. So this can be there's a lot of work we have done in this, and this project was funded by Intel, right? And okay, this is my PhD student now joining University of Cork in Ireland. So, so these are all the works, and so I will just close it here. So my department, that is the School of Information Technology of University of Calcutta, we do a lot of work in the domain of data science, ML, and AI. We are working in computer visions with multiple funded projects. We are also working in prediction of the forecasting the renewable energy. We are basically working on the solar and wind. So provided you give me the present weather conditions and the past production in terms of the solar energy and wind energy, I can predict, right? I can forecast what will be the amount of solar or wind energy in the next few days, so that you can prepare the grid properly. Because this is very important, because nowadays renewable energy sources are connected to the grid. If you cannot predict the energy coming from renewable energy, and if it varies a lot, then it affects the grid and affecting the grid is basically a real costly for the people as well as for the services. So renewable energy prediction is coming to a great activity across the world, right? We are also doing a lot of work in text analytics. We are focusing on some activities like AI for signature analysis, and whether ML can be used for generating the signature patterns of a crypto cipher. We recently completed a project funded by DRDO, Defense Organization of India. We are also looking into the hardware security funded by Intel, and we are looking on blockchain for IoT analytics, which is funded by TCS. And there's another big domain which I also work, which is called quantum computing, which I didn't say much here. So quantum machine learning is also coming up in a great way. We have a small project with Japan, but we are working a lot with our international collaborators in this domain, right? And this is also a very upcoming field that is, as we know, that quantum computing is the next computing paradigm, right? It's already there. That means, and it's growing in a large scale. So now people are shifting from the classical computing domain and trying to see that whether the algorithms, very popular algorithms, how they perform in this particular quantum systems and quantum paradigms. So the quantum machine learning is also a very good direction, right? So what I try to focus here is that there are really a lot of opportunities for the students who are now doing masters and PhD and trying to focus on machine learning. The sky is a very big sky, right? It was so many opportunities and so many domains were not there when we started our masters or PhD, but now it looks like you can that brings so many projects and so many PhDs, right, in this domain of AI and ML. So many articles are there in AI and ML, and right, and that's the motivation I just wanted to pass. Okay, some of the interesting work so that they can inspire you, and you need to think and plan and look into the work, what is going on. Try to plan a laboratory and try to be hands-on also, right? The another important thing in AI and ML is that I have seen the students jump into the packages and just try to see that which package works good, and whatever gives the best results, they come up with that. Hey, I have done the problem, solved the problem. So you don't do AI ML in that way, because that is a very mechanical AI ML. So the way you need to know is that you need to know the fundamentals, how the neural networks work, what is meant by each of the convolution need a layer, right? If we try to make it 2D, or we make it 1D, or we skip certain layers and push the lower level features to the higher level features by skipping some of the layers, what they actually doing in my feature space. Because you try to understand, I didn't give that lecture here because it's a motivation lecture, but when you take a class, I focus mostly on the feature space, because feature space is the thing if you want to learn data science or ML. And if you understand feature space well, right, all the techniques what you do in the AI and ML is actually building the feature space first, right? To build the feature space, and all the modifications what you can do in the AI ML is basically how intelligently you can build a feature space so that the next job, right, whether it is prediction or it is classification or it is clustering, can be done very well. Okay, so those are the things you need to know, and you need to know that means this processes what has been done, either transfer learning, okay, that means and different types of learning techniques, right? You need to understand them in the philosophically, and then if you understand the philosophy well, I think choosing the package and trying a particular package, okay, implementing that particular technique is not a very hard task to do. Okay, so thank you once again, and I thank you all. And if you have any questions, I will be very happy to answer.
Prof, thank you so much. Guys, if you have any queries or if you want to ask any suggestions on your work, on your information, you please go ahead. It's up to you now.
Yes. May I go ahead?
Yes, Mr. Jalal.
Yes, sure.
Thanks, Professor, for the wonderful session. A quick question on the bias side. Now, I'm just working on assessing certain chatbot systems. So you talked about the training model, right? Where you give a specific set of data and then you train the model, and that probably there is a chance to create a bias. Is there any benchmarks or something I can use when it get into application in a practical life? For example, if it's a chatbot for a bank, let's say it processes, let's say 10,000 communications per day or per second. What could be the training data volume that should be used? Is there any sort of benchmark for that or something that can give me a guidance? I hope my question is clear.
Yes. A very good question. Actually, that means to make this algorithms bias free, right? There should be, you have pointed a right effort that the effort should be taken so that the clean training data, right, bias-free training data are being available, can be accessed and are made available, so that this can be done. I cannot just tell like that. That means offhand that what are the things, but I will remember your question, right, and I will soon get back to you on this, right? If they're for the chatbots, basically for the transaction and data when this exchange, right, how you can make them, because sometimes business will tell that, hey, don't make them, and then you push them in a little bit biasness, but I think this is a very, very good question, and I will try to get that if there is something available.
Thank you, Professor. Thanks a lot.
Prof, I would like to introduce Mr. Jalil is our PhD student.
Excellent.
He's on the initial part.
Excellent. So I hope that means, what is the domain you are working in? This domain you are working that?
I work in cybersecurity and technology audits.
Excellent. So that means it is good that means you have focused on a very good field and also doing PhD. We will be in touch. Okay.
Sure.
Thank you.
Thanks.
Thank you. So, is there any other questions or any suggestions? Else? Okay, fine. Thank you all of you. Thank you for joining. Thank you so much, Prof, for giving us such an excellent, wonderful session. I hope our students from Master of Computer Science, Master of Computing, and also PhD students, both IT and computer science students, all have been getting in a wonderful session, and it will be very informative, and they set up their paths to pursuing their research. Thank you, guys. Thank you for joining, and see you soon. And thank you, Prof. And we also expect such more collaborations.
Sure.
It is not a you're coming to LinkedIn.
I will.
So we expect much more. Thank you, guys. See you soon. Thank you for joining.